This video we're going to be looking at how to calculate limiting reactant. So limiting reactant means that it is the reactant in an equation that prevents you from using up all of your other reactant and creating a maximum amount of product. It's a pretty self-explanatory name. So here's an example. I have moles of gas of each reactant are given. So this is my balanced equation. I need to always work with a balanced equation because limiting reactant is at its heart a stoichiometry problem on steroids. So I have 5 moles of oxygen gas reacting with 6 moles of aluminum solid. 3 questions. What is the limiting reactant? How many moles of aluminum oxide will be produced? And how many moles of excess reactant remain? Well, if you remember from the stoichiometry problems, if I'm going from moles A to moles B, I only need to use one set of parentheses. So this is the easiest limiting reactant problem and therefore probably one you're not going to encounter unless you're really lucky. So I have 2 options as to how to tackle A. I can either pick one reactant and find out how many of the other moles of reactant that would be needed. So if I picked 5 moles of oxygen gas, I use the mole ratio for my balanced equation, and I find that I need 6.67 moles of aluminum. Well, I only given 6 moles of aluminum, so aluminum is the limiting reactant. Well, what if I picked the 6 moles of aluminum instead? Well, if I pick the 6 moles of aluminum, using my mole ratio, I find that I need 4.5 moles of oxygen gas, but I was given 5 moles, so oxygen gas is in excess. Either way, you'll find out that aluminum is the limiting reactant or that oxygen is the excess reactant. So in limiting reactant, there's only one limiting reactant. Everything else is in excess. The other option is that you could compare the yields of each reactant. So you could say, if I were to use 5 moles of oxygen, and I'm assuming that I have enough aluminum, how many moles of aluminum oxide would be possible to make? And using the mole ratio this time from oxygen and aluminum oxide, I find out that I could make, if I could use up all the 5 moles of oxygen, 3.33 moles of aluminum oxide. And then compare it to if I used my 6 moles of aluminum. Well, if I use my 6 moles of aluminum, using my mole ratio of aluminum creating aluminum oxide, if I could use up all the aluminum, I can only make 3 moles of aluminum oxide. So what's preventing me from making the maximum amount of aluminum oxide is my aluminum, so my aluminum is my limiting reactant. So whether you choose option 1 or 2, you're going to end up with the same answer, which is aluminum is the limiting reactant and oxygen is the reactant in excess. Fewer moles of aluminum oxide are possible from aluminum, so aluminum's the limiting reactant. The nice thing about these options is that they can help you find out B or C depending on what you used. So if you used option 2, you now already know, and you've answered the question for B, wow, 3 moles of aluminum oxide are created. If you used option 1, you'll have to then choose the 6 moles of aluminum, do the stoichiometry to find out that 3 moles of aluminum oxide were created. But fear not, if you used option 1, that helps you solve for C. Because option 1 showed that I had excess oxygen. I only needed 4.5 moles of oxygen. I was given 5 moles of oxygen, so I can say, oh, I only have 0.5 moles remaining of my oxygen. If you used option 2, then you know that oxygen is excess. You have to use your moles of aluminum to figure out how many moles you would actually use, and then again plug it in. How much oxygen I was given minus how much I actually needed will give me how much excess remains, or is how much left over. So that's the easiest way. The more complicated way is if I give you everything in grams. So again, we're going to use the same balanced equation. This time I'm going to give you grams. So again, I'm working with my balanced equation, and if I'm going from grams of oxygen, which is grams of A, to grams of aluminum, looking back on my stoichiometry, I remember that I need to have 3 conversions. And here I'm showing the conversions as I did in the dimensional analysis, not as parentheses, but as this grid. So whichever way works for you, I don't care. So I am given 84 grams of oxygen and 90 grams of aluminum, and I'm asking myself the same questions. What is the limiting reactant? And now I'm asking for how many grams of my aluminum oxide are actually produced, and how many grams of my excess reactant will remain. So again, I'm going to be looking at different options as to how to tackle this. Option 1, I will want to know how many grams of each reactant I would actually need. So I choose. I can either choose 84 grams of oxygen, and I set up my 3 conversions, converting grams of oxygen to moles, using the mole ratio as given in my balanced equation, and using the periodic table to find grams of aluminum. And I find that I need 94.5 grams of aluminum. I'm only given 90 grams of aluminum, so aluminum is the limiting reactant. If I had chosen aluminum and run this through, I would find that I need 80 grams of oxygen. I'm given 84 grams of oxygen in my word problem, so oxygen is in excess. Again, no matter which reactant you choose, you will find out that the other one is either the limiting reactant or it's the reactant in excess. The option 2 is that you could use each reactant and using the balanced equation, find out how much of the product you could possibly make if you could use it all up. So I'm using grams of oxygen to find grams of aluminum oxide. Again, 3 parentheses. My molar mass of aluminum oxide is 102 grams per mole. And I find that if I use up all of my 84 grams of oxygen, I could make 178.5 grams of aluminum oxide. But if I'm looking at my aluminum, I can only make 170 grams of aluminum oxide. So again, if you choose option 2, you'll find that you are able to make fewer grams of aluminum oxide from your aluminum than you are from your oxygen, so aluminum again is the limiting reactant. Again, if you chose option 2, you've already answered B, in which you found out that you can only make the lower amount, the 170 grams of aluminum oxide. If you chose option 1, you'd have to use the limiting reactant, do the stoichiometry to find out how many grams of the product you could make. And then finally for C, if you used option 1, you may have had to do extra work for answering B, but you already know that you have 84 grams of oxygen given and you only needed 80 grams of oxygen, therefore 4 grams of oxygen remain in excess. If you used option 2, you would have to use the given grams of your limiting reactant, Al, to find out how many grams of your excess reactant you would actually use, and then subtract that from the given amount. So again, all of this requires a facility, an ease with the stoichiometry and understanding how many conversions to use and how to set them up. Make sure that you are very firm in your understanding of how to use stoichiometry and dimensional analysis. So always go back to those videos if you need to.